Why does fire exist? Simple question. You witnessed fire 1,000 times. Campfires, candles, stoves. You strike a match, something burns, flames appear. But why? Most individuals never inquire. Fire just is. It's hot, it's bright, it destroys things. That's all you need to comprehend, correct? Incorrect. When you genuinely inquire what fire is, when you excavate into what's actually occurring when something burns, you discover something so beautiful, so perfectly connected to everything else in nature that it transforms how you observe the world. Fire is not just a thing that occurs. Fire is a window into how atoms behave, how energy moves, how the sun powers everything, and why trees exist in the first place. Let me demonstrate. The fundamental tension starts with a piece of wood-dead trees sitting there doing nothing, and oxygen in the air floating around, also doing nothing. The wood has been sitting there. The oxygen has been there the whole duration. Nothing's occurring. They're just there. But the atoms prefer each other to different degrees. Oxygen, for instance, in the air would prefer to be next to carbon. And if they're getting near each other, they snap together. But here's the problem. If they're not too close though, they repel and they separate. So they don't realize that they could snap together. This is the fundamental tension. Carbon and oxygen desire to be together. Being together releases energy, a lot of energy. That's the stable state, the low energy configuration. But to arrive there, they have to first get close. And getting close means climbing over a barrier. It's just as if you had a sphere that was attempting to climb a hill, and there was a hole it could descend into, like a volcano hole, a deep one. It's rolling along. It doesn't descend into the deep hole, because if it starts to climb the hill, it rolls away again. But if you could make it advance fast enough, it'll fall into the hole. And so if you have something like wood and oxygen, there's carbon in the wood from a tree, and the oxygen comes and hits the carbon, but not hot enough, it just departs again. And the air is always coming. Nothing's occurring. The atoms are bouncing off each other constantly, millions of collisions every second, but they're not reacting because they don't possess enough energy. They hit, they bounce, they separate over and over. The wood just sits there. The oxygen just floats around. Nothing changes. This can continue for years, decades, centuries. A piece of wood can sit in the presence of oxygen for 1,000 years and nothing occurs. The atoms desire to react, but they can't surmount that barrier. The catastrophe begins. If you can accelerate it by heating it up somehow, somewhere, somehow initiate it. A few of them come fast. They advance over the top, so to speak. They come close enough to the carbon and snap in. And that provides a lot of jiggling motion, which might strike some other atoms, making those advance faster so they can climb up and bump against other carbon atoms. And they jiggle and they make others jiggle, and you acquire a terrible catastrophe which is one after the other. All these things are advancing faster and faster and snapping in, and the whole thing is transforming. That catastrophe is a fire. It's just a manner of examining it. And these things are occurring. They perpetuate. Once it initiates, it keeps on continuing. The heat makes the other atoms capable of reacting to make more heat, to make other atoms, and so on. This is the key to understanding fire. It's not that something magical occurs when you light a match. It's that you're providing a few atoms enough energy to surmount that barrier. And once they do, they release energy. That energy makes other atoms move faster. Those atoms surmount the barrier. They release more energy, and so on. It's exponential growth. One reaction triggers two. Two trigger four. Four trigger eight. The number of reacting atoms doubles and doubles and doubles. Within a fraction of a second, you possess billions of atoms all snapping together simultaneously. That's why fire explodes into existence. It's not gradual. It's sudden because it's a chain reaction, a runaway feedback process. What? Heat really is, so this terrible snapping is producing a lot of jiggling. And if I position with all that activity of the atoms there, and I position a cup of coffee over that mass of wood that's performing this, it's going to acquire a lot of jiggling. So that's what the heat of the fire is. Heat is not a substance. It's not a fluid that flows. Heat is atomic motion. The faster atoms jiggle, the hotter something is. When fire releases energy, that energy transforms into making atoms move faster. That's heat. That's temperature. That's what you sense when you hold your palm near a flame. Fire is not a substance. It's not a thing. Fire is a process. It's this catastrophic chain reaction where atoms are snapping together faster and faster, releasing energy, making other atoms move faster, which makes more atoms snap together. It's a cascade. Once it initiates, it feeds on itself. The heat from the reactions provides the energy needed to make more reactions occur. It's self-sustaining. That's why fire spreads. That's why it's hard to halt. The heat makes atoms jiggle fast enough to react. The reactions produce more heat. The more heat makes more atoms react, around and around, a feedback loop. And the only manner to halt it is to break the loop, cool it down below the threshold, remove the fuel, remove the oxygen, cut off one leg of the triangle, and the process collapses. Where wood comes from. And then, of course, if you observe, this is what occurs when you just start to consider. You just continue on and wonder, how did it initiate? Why is it that the wood's been sitting around all this duration, with the oxygen all this duration, and it didn't perform this earlier? Where did I acquire this from? Well, it came from a tree. And the substance of a tree is carbon. And where did that originate from? That comes from the air. It's carbon dioxide from the air. Individuals examine trees, and they believe it comes out of the ground, that plants grow out of the ground. But if you inquire where the substance originates from, you discover where does it originate from. The trees come out of the air. They surely come on, no, they come out of the air. This is one of the most beautiful misunderstandings in all of nature. Everyone comprehends trees grow from the ground. You plant the seed in soil, the tree grows. Obviously, it came from the soil, correct? Incorrect. The carbon dioxide in the air enters into the tree and it transforms it, kicking out the oxygen and pushing the oxygen away from the carbon and leaving the carbon substance with water. Water comes out of the ground, you observe. But how did it acquire in there? It came out of the air, didn't it? It came down from the sky. So in fact, most of a tree, almost all of the tree is out of the ground. I'm sorry, it's out of the air. There's a little bit from the ground, some minerals and so forth. The minerals provide you the ash when you burn wood, that tiny bit of residue left behind that came from the ground. But the wood itself, the bulk of the tree, the substance that burns, that's carbon from the air. That's water from the rain. Almost nothing came from the soil. Proof tor arf. Experiment. Now let me prove it to you. Take a pot of soil, weigh it, plant the seed, water it for years, let the tree grow big and heavy. Now excavate the tree and weigh the soil again. The soil weighs almost the same as it did before, maybe a tiny bit less. Some minerals acquired, absorbed, but the tree weighs hundreds of pounds more than it did as a seed. Where did all that mass originate from? Not from the soil. The soil didn't lose hundreds of pounds. It came from the air. This experiment has been performed. A Dutch scientist conducted it in the 1600s. He was attempting to figure out where plant mass originates from. He weighed everything carefully. The soil barely changed weight. The tree gained enormous weight. He concluded correctly that the tree did not originate from the soil, but he thought it came from the water. He was close. The water is part of it, but most of the mass is carbon pulled directly out of carbon dioxide in the air. The role of sunlight. Now, of course, I conveyed you the oxygen and carbon stick together very tight. How is it the tree is so intelligent as to manage to take the carbon dioxide, which is the carbon and oxygen nicely combined, and undo that? So easy. Life possesses some mysterious force? No. The sun is shining, and it's the sunlight that comes down and knocks the oxygen away from the carbon. So it takes sunlight to acquire the plant to function. And so the sun, all the duration, is performing the work of separating the oxygen away from the carbon. The oxygen is some kind of terrible byproduct which it spits back into the air and leaving the carbon and water and material to make the substance of the tree. This is what makes life on Earth possible. The sun is performing work, genuine physical work. It's pumping energy into the system. That energy acquires used to push systems away from equilibrium, to create order out of disorder, to construct structure. Trees are constantly performing this, sucking in carbon dioxide, tearing it apart, constructing themselves out of the carbon, releasing the oxygen back into the atmosphere. That's what photosynthesis is. It's the tree using energy to undo what fire performs. Fire takes carbon and oxygen and snaps them together. Trees take carbon dioxide and rip it apart. The tree is using sunlight to perform work, to store energy, to construct structure. And that structure, that's potential energy. The carbon and oxygen are held apart. They desire to be together, but they're separated. Energy is stored in that separation. Stored sunlight released. And then when we take the substance of the tree and position it in the fireplace, and there's all the oxygen made by these trees, and all the carbon, they would much prefer to be close together again. And once you permit the heat acquired, initiated, it continues, and it makes an awful lot of activity while it's advancing back together again. And all this nice illumination, and everything comes out, and everything is being undone. You're advancing back from carbon and oxygen back to carbon dioxide. And the illumination and heat that's coming out, that's the illumination and heat of the sun that went in. So it's sort of stored sun that's coming out when you burn a log. Consider about that for a second. The tree spent years collecting sunlight bit by bit, photon by photon, using that energy to pull carbon out of the air and construct itself. It stored that energy in its structure. Then you cut down the tree, you permit the wood dry, you stack it in your fireplace, and when you light it, all that stored sunlight comes pouring back out. The carbon that the tree worked so hard to separate from oxygen is collapsing back together. The energy that was stored is being released. Fire is just stored sunlight escaping. A log burning in your fireplace is the sun shining again. The illumination you observe flickering in the flames, that sunlight that fell on leaves 5 years ago, 10 years ago, 50 years ago, stored as chemical bonds, released all at once. Every photon from the fire is, in a sense, a recycled photon from the sun. The energy is the same. It went in as sunlight, acquired, stored as structure, and comes back out as fire illumination. Why spontaneous combustion doesn't happen now? You might inquire, why doesn't the wood just spontaneously catch fire? If carbon and oxygen desire to be together so badly, why do you need to light a match? Because of that hill I mentioned earlier, the activation energy. At room temperature, the atoms aren't jiggling fast enough to surmount the hill. They're bumping into each other, but they're not reacting. The wood and the oxygen are stuck in what we call a metastable state. They desire to react, but they can't initiate. It's like a boulder balanced on top of a hill. It desires to roll down. That's the lower energy state, but it's sitting in a little depression at the top. It's stable as long as nothing pushes it. But if you provide it just a little nudge, it rolls down and releases a lot of energy. That's what the match performs. It provides the nudge. It heats up a small region of the wood, making those atoms jiggle faster, acquiring them over the activation barrier. Once a few reactions start, they produce enough heat to trigger more reactions and the fire spreads. This is why things don't just spontaneously combust. The universe is full of metastable state systems that desire to release energy but can't initiate. Wood and oxygen, gasoline and air, provisions and oxygen in your cells. They're all waiting for a trigger, a spark, an enzyme, something to acquire them over that initial barrier. And once they start, they run on their own. Where oxygen came from. Here's another thing that should astound your mind. The oxygen in the air, where did that originate from? From trees, from plants, from photosynthesis. For billions of years, plants have been ripping carbon dioxide apart, keeping the carbon and spitting out the oxygen. All the oxygen you breathe, all the oxygen in the atmosphere, it's waste. It's a byproduct. Plants don't desire it. They throw it away. The early Earth possessed almost no free oxygen. The atmosphere was carbon dioxide, nitrogen, water vapor. Then photosynthetic organisms evolved. They started dumping oxygen into the atmosphere as waste. For them, oxygen was poison. Many of those early organisms died out when oxygen levels rose. But some organisms evolved to use that oxygen, to burn provisions with it, to extract energy from it. And that oxygen is what makes fire possible. The seep of life. So here's the cycle. The sun shines. Plants use that sunlight to break apart carbon dioxide, constructing themselves out of carbon and releasing oxygen. Animals, including you, consume the plants or consume other animals that consume plants. And you burn that carbon, combining it back with oxygen to release energy. That burning occurs inside your cells. It's called respiration. It's the same process as fire, just slower and more controlled. You're taking carbon-based molecules and combining them with oxygen to release energy. The carbon dioxide you exhale is the same carbon dioxide the plants absorbed. It's a cycle. Sun to plants to animals and back. Carbon circulating, oxygen circulating, energy flowing. Fire is just that cycle, sped up and visible. When you burn wood in a fireplace, you're performing exactly what your cells perform when they burn sugar. Same reaction. Carbon plus oxygen makes carbon dioxide and releases energy. The only difference is speed and control. Your cells perform it slowly, carefully, capturing the energy in useful molecules. Fire performs it all at once, releasing the energy as heat and illumination. But it's the same chemistry, the same process. You are, in a very genuine sense, a slow fire. The mechanics of burning. Let me make this even more concrete. When you burn wood, you're converting chemical energy into heat and illumination. The chemical energy was stored in the bonds holding the wood's molecules together. Those bonds took energy to create. That was the sunlight the tree absorbed. Breaking the bonds and forming new bonds, carbon dioxide and water releases that energy. The heat, you sense that, atoms jiggling faster because energy was released. The illumination you observe, that's atoms and molecules acquiring excited, literally electrons jumping to higher energy levels and then falling back down, emitting photons. When carbon and oxygen snap together, the energy released doesn't just disappear. It transforms into motion, atoms moving faster, molecules vibrating, electrons jumping to higher orbits. And when those electrons fall back down, they emit illumination. That's the glow of the fire. That's the flame. Different atoms emit different colors. Sodium makes yellow. Copper makes green. Strontium makes red. That's why fireworks function. Different chemicals burn with different colors because they possess different electron configurations. The smoke, that's tiny particles of carbon and other material that didn't fully react floating up because they're hot and less dense than the surrounding air. The ash, that's the minerals, the material that wasn't carbon, the bits that came from the soil. That's the tiny fraction of the tree that didn't originate from the air. Everything else, the carbon, the hydrogen, the oxygen, has turned into gas. Carbon dioxide and water vapor, invisible products floating away. The mass didn't disappear. It turned into gas and drifted off. The final question. Now here's the question you should be inquiring. Next question. How is it the sun is so jiggling, so hot? That's a different story. I've acquired to halt somewhere. I'll leave you something to imagine.